morning, everybody. Welcome to our fireside chat. My name is Terry Haygood. I'm the cyber infrastructure facilitator for Jackson State. And I want to read our panel proposed abstract. The panelists will discuss, before I allow them to introduce themselves, I'll read the abstract. Panelists will discuss throughput computing and artificial intelligence and machine learning. We'll learn about Jackson State University's model for building an AI-ready cyber infrastructure and the University of Wisconsin-Madison's NAIRR pilot demonstration project that applied throughput methodologies to automate the training of ensembles of AI models across capacity-provided campuses, national facilities, and commercial cloud. I don't know about a lot of you all, but when I heard that we were going to do a fireside chat style session, I looked it up. Because I was thinking Deep South, summer, fireside, just didn't quite go together. So instead, I'd like for you to imagine a backyard barbecue. I'm personally waiting for a ribeye to come off the grill, medium well. Some of you may be waiting for like a ginger soy infused portobello mushroom, whatever it is. But before we get going, let me read the definition. A fireside chat is an informal conversational discussion or interview. It typically involves a host or moderator, myself, conversing with a guest speaker or a leader addressing an audience directly. It is designed to be relaxed, engaging, personal rather than formal scripted presentation. So if you have questions, please don't hesitate to shoot them at us, and we'll do our best to answer them. So to my right is Dr. Loretta Moore, and I'll allow her to introduce herself, and then we'll go to Dr. Dent and Dr. Miron.
Okay.
And also, one second, Dr. Moore, please tell us something about yourself that the people in the room may not know.
Okay. Very personal, isn't it? I'm Loretta Moore. I'm professor of computer science at Jackson State. I've been in higher ed and other places for 34 years. I started when I was like 5 years old. That's something they probably didn't know.
They probably didn't know.
And I started in chemistry, and I blew up a lab. And so I switched to computer science. Most people don't know that. I don't go around bragging about that.
Blew up a lab.
Just fire. Long story. Yeah.
Well, I'm glad you got to computer science.
Yes.
Dr. Dent.
Okay. Good morning.
Good morning.
All right. See, everybody knows how to say good morning now.
Yeah.
Yeah, they're really great. Good morning. I'm Deborah Dent. I am the CIO. I have to say that real slowly because I messed that up yesterday. But I am a Chief Information Officer at Jackson State University. I've been at Jackson State now for about 13 years. Prior to that, I was with the Department of Defense, U.S. Army Corps of Engineers, Engineer Research and Development Center. So I was with a research lab for the Corps of Engineers for, I'm going to tell you how long. You ready? For 37 years. So she started when she was 6, and I started when I was born. I was just born there, okay? Okay, so something that nobody knows about. Okay, so way back in the day when I first started, we had to work on these big computers that was as large as this room, but the memory was probably just about 256K, real slow, and we had to use punch cards. And I was a co-op student, so they had some passwords. And so we were mischievous, the co-op students, and we hacked the system. Okay, so that was so long, and they can't do anything about me because the statute of limitations have passed. Wow. So I was a hacker when I was a kid. Okay.
Watch out, Danny.
I forgot he was there.
Dr. Miron, please.
Yeah, my name is Miron Livny. I am a faculty at the Computer Science Department at the University of Wisconsin-Madison. I started as a physicist. I probably nobody knows that I wrote my first computer program in '67.
Okay.
Yeah, so be- there were no passwords then. The passwords were invented after that. Yeah, so that's we are ready to go.
Very nice.
At
We'll
least you
keep the
didn't blow
show.
anything up.
Yeah, at
No.
least, yeah, no fires, no fire department.
No fire department.
So before we get going, I wanted to take a poll of the audience. By show of hands, those who are associated with HBCUs, please raise your hand. All right. How about TCUs? Okay. HSIs? MSIs? All right, so the majority of the crowd is either associated with HBCU or TCU. All right. Well, the reason I asked that, because what I wanted to know from each of our panelists is, why do each of you have a passion for this type of work with the MSCC program and its institutions? And Dr. Moore, do you mind?
Sure. For me, when I graduated from Jackson State with a BS in computer science, I went to work for AT&T Bell Laboratories. So while we had taken, and students had taken courses in operating systems and networks and computer architecture, when I got to Bell Labs out of New Jersey, everybody had a computer. I said, oh, well, where's my computer? And they brought all these pieces and they just dropped them on the desk. I was like, wow, I don't know what to do with this. But you know, there's always somebody around that sees what's happening. They'll come, we're gonna help you set it up. And even though I'd taken a networking course, when they took me in the lab with all of the machines and everything, I was like, wow, I think I saw a picture of these in the book. You know, I passed the class, but I didn't know what to do with it. So it was a passion to, 13 years later, I went back to Jackson State, and I made sure that they had laboratories so people could engage and not just get the conceptual or theoretical. So I know that our students are extremely talented across all institutions, but the goal was to make sure we had access to equipment and technologies to prepare us for the workforce.
All right, all right. Dr. Miron?
Yeah, I get frustrated when I see or experience educators and researchers that don't dare to think big or to think doing more what they are doing today because they don't believe that they will have the capacity to implement their dreams. So for decades, my group has been doing our best to enable researchers and educators. I would say we have more success with researchers and less with educators to think bigger with the help of capacity. And I think that the MSCC is an important venue to help the many researchers and educators out there to think bigger. Because typically I come and I say, okay, if I give you 1 million core hours, what are you going to do? And unfortunately, not everyone is prepared to think big. So hopefully as you leave this panel today, you may be willing, you may start thinking bigger and see a way to implement your dreams.
And finally, one of the founders of the MSCC.
Okay,
Dr.
so I have a passion for it because my entire career, I told you I worked for the Department of Defense, and I started out as a programmer, and we started developing large systems, and I always worked with all types of researchers. I was a computer scientist, but I had to work with engineers, right? And physicists and mathematicians and everything. And so over the years, we went through all kinds of systems. I've seen the development go across the board. But one thing that we had there was, where we was located, is something that was called the Major Shared Research Center. And it was for the high performance computing for the DOD. So for the entire DOD, where we were located in the little town of Vicksburg, Mississippi, we provided resources for all of DOD. And so they didn't have to worry about everybody didn't have to have their own resources. We were centralized there, that we would provide the services and everything we needed. And so when I retired and I came to Jackson State, it was like, okay, we need the same resources, because it was totally different. I came from a highly resourced till we didn't have that type of resources. So then when we started the MSCC, we said we can do more together than we can alone. And that was one thing that we did there, is we shared our resources. So that's why the MSCC is critical in us getting to where we want to go, but we got to get there by sharing our resources.
All right. I appreciate you all sharing your passions for that. Dr. Moore, you've had experiences in higher education, you've held positions in government agencies, now you're faculty. What makes your experiences unique by working with the various institutions?
Okay, I think I've worked on a departmental level in computer science as an ABET commissioner, and I've worked across the institution as associate dean and vice president for research. And then when I had the opportunity to go to the National Science Foundation, I served as section head for the EPSCoR program. Everybody familiar with the EPSCoR program? So it makes sure there are 28 states and territories, we call jurisdictions, and they receive less funding than all of the other states in the U.S. And I think if you combined it at one time, it's probably less funding than California. And so it was to ensure that funding got to states and institutions. Now these jurisdictions, they have a lot of HBCUs, they have tribal colleges, they have HSIs, and so working with the team at the National Science Foundation to make sure that we have programming that can reach those institutions and they're not just competing with the big schools. And so one of the things we did, and I won't tell Dr. Dent stories, but the conference out in Montana, right? And so I met some individuals there from the tribal college, and we started to work with them as an NSF program to ensure that they could get access to things such as the Includes program, or we created special tracks for like the cyber infrastructure so that you could compete on what your needs are, because what you need is going to be different from what Wisconsin-Madison needs, so that we could look at these institutions and make sure that they address those needs. Now, Terry, I was really thrilled when you went to the user school and you found out about the PATH project and you started talking about HTC. And I was like, well, maybe when he gets back, he'll explain what HTC is. You want to tell the audience about that program?
Yes. This was in August of 2023. I went to the HTC User School at the University of Madison, University of Wisconsin-Madison. Beautiful school. If anyone has a chance to attend that HT User School, I highly encourage you to do so. But that's where I met Dr. Miron. Dr. Miron had come in, we had finished a training session, we were about to take lunch, and I think we were introducing ourselves, and I said, of course, my name is Terry Haygood, I'm from Jackson State University, and I saw a glimmer in Dr. Miron's eye. He looked down at me. So we were at lunch. I was sitting eating with Russell Hoffman, and Dr. Miron was going around talking to different people, and he stopped at our table, and he asked me, he said, so what are we going to do? And I said, everything. I couldn't think of anything particular, but we're going to do some big things. And he said, well, since the contingency came out, I think it was in 2016 maybe, around there, 2016, 17, 18, and he said, well, we want to continue the work with high throughput computing at Jackson State. There was a group that came out, and I'm just all ears because I'm kind of new. And so I'm just listening for anything I can take back to Jackson State and find out about. And finally he gets to a name that I knew. And I said, well, let me do some research about this. Got back to the campus, talked to the points of contact, started peeling back the onion, and realized that we had demand for high throughput computing at Jackson State. So I immediately called Dr. Miron back and said, yes, you know, I did a little research and I found out that high throughput computing is something that would be great for Jackson State. What do I need to do? How do we get started? And Dr. Miron introduced me to his team, and I would say the rest is history, but we're still working to make sure that we build this system out, get it out to our researchers, our educators, and use it to the full potential that we want to, that it deserves. So that was my experience at the user school.
That has brought us all together.
That's brought us all together here today. With that being said, what I'd like to do now is ask Dr. Miron and Dr. Moore. You get a break, Dr. Dent? You get a break? Could you please describe your current projects and how your work specifically addresses?
Can I
Absolutely.
piggyback out of the script? You see, all of you guys have a script.
Hey, there's room for this.
I'm free.
There's
Now,
room
Dr.
for this.
Miron asked that we
All
not
right.
send him
This is
questions.
good.
Yeah.
He wants to go off the cuff, so.
So, a couple of things. First of all, we keep running this summer school, and this one is already fully booked, and we have over 60 students coming, and we hope to have another one next year. So, assuming that we can keep it under the same structure, then the students that we accept, about 60 of them, we have funding to keep them entertained for a week. So that's something for you to hopefully take home with you and consider for next year. The other concept that I want to piggyback on is the notion of sharing. And that is easy said, but difficult. I still remember on one of my driving around in the South in Tennessee, there was the big sign that says, sharing is caring. And sharing has been for decades. We started over 40 years ago, the underpinning principle of what we are doing. So I know that it sounds like motherhood and apple pie, but it's extremely powerful, but difficult. And I strongly believe that sharing is a key element of the long-term success of the MSCC community. And what we do on our end is we develop the technologies and the methodologies to facilitate sharing. Because once you decide to share, then the question is how do you implement and how do you monitor and how do you do all the stuff that related to sharing. We may talk about it later, but one of the sharing environment that we operate under funding from the NSF is the Open Science Pool, and now the Open Science Data Federation. So the Open Science Pool is going across 80 institutions across the US, and they share their capacity. And some of what you will hear later about what we do for training is the result of this sharing. So it's extremely powerful once you buy into it, whether as a user or as a provider. So please take with you a commitment to share, and we'll be happy to help you to make it happen.
That's perfect.
So now you can.
Well, I would like for you to continue. If you
Oh,
wouldn't
then,
mind talking about your NAIRR pilot demonstration.
When is dinner? No.
Would you mind telling us a little bit about your NAIRR pilot demonstration?
Yeah, okay. So how many of you are familiar with the National AI Research Resource, NAIRR? Okay, good. So it's out there. So now imagine that you would like to train or fine-tune or whatever you call it, a model. And you got allocation, which, by the way, I hate allocations. That's a different discussion. On, let's say, half a dozen of the NAIRR resources, and you want to do your training. And you want to train 100 models. That's a different discussion of how AI models can benefit science or researchers, not ChatGPT. But that's, but we see in our community researchers that have a need to train ensembles of models. So what we did as a demonstration is to use our throughput computing capabilities, automation, tools, to train. I think we are today around 1,300 epochs across a dozen sites. Because what we are doing is that we are taking a training, assuming you are familiar with it, is a sequence of epochs. Epoch, epoch, epoch. So what we say is rather than devoting a resource to the entire training, we only devote a resource for one epoch. And I will even tell you a secret. You may devote it just to a mini batch, because inside the epoch, there are these smaller pieces which are always startable. If you really think about what training is, it's somewhere between extremely basic to stupid. Do it, and then do it again, and then do it again, and then do it again, and maybe at the end you will get something useful. If I told you to do it originally and didn't call it AI, you would have said, what's wrong with you? So the demonstration is to take the technologies that we have for throughput computing. Just to give you a feeling, the Open Science Pool, in a year, we execute over 400 million jobs for researchers. So we are pretty good in taking a lot of, excuse my English, crap and running it around 80 institutions. So by first principles, whether these jobs are epochs or not is just becoming a detail. So the demonstration is we can train your model if you're willing to wait for it to happen an epoch at a time, or especially if you have several epochs. And as a thought, here's an example where you may want to train an ensemble of models. You are teaching a class. You give each student a data set, and you say, train or fine-tune a model with the data that I gave you, and then run some inference to see how good it is. So you have a class of 15, 20 students. Suddenly you have 20 models that you want to train. And I think you will all agree that it's easier to give them an allocation of a resource for half an hour per epoch than to dedicate a GPU to them for the entire training. So suddenly, with the result of our demonstration, you can bring the capacity of NAIRR or the capacity of the OS pool or whatever capacity you get out of sharing to your classroom and say, hey kids, go and train, go and fine tune, and then see how good the inference is by trying to figure out whether this picture is a dog or a cat. Because for me, all AI is I have a bunch of pictures. I trained a model, and then I can give it a picture. It will tell me whether it's a cat or a dog.
All right. Thank you. Thank you. That's a perfect lead-in, Dr. Moore, because you teach a AI class
Yes.
where you are involving high-throughput computing in your teaching. Would you mind talking to us a
Yes,
little bit about that?
and I'm hoping Dr. Miron will give me all the secrets to make this a success. So I'm teaching an undergraduate artificial intelligence class. And the approach I tried this past semester was, rather than following the book solely, we started with playing games. So students came in on the first day and, they played tic-tac-toe. And some of them said, what is this tic-tac-toe? I was like, oh, they're so young. And they played each other, and we tried to get them to capture their rule and how would they represent the state. And we talked about the search space. And then we went to 8 puzzle, and then we started with N queens with something smaller. And so then they had to be able to sort of manually or to a limited extent on their computers play these games using the uninformed search algorithms like Dent first, breadth first, iterative deepening, and move on to informed search, such as with A*. How would they integrate minimax and alpha beta pruning? And so their machines started to really slow down. And Terry said, hey, HTC could work for them. And so that's what we're trying to do, is to let them see, the limited power of their machine versus the power of the HTC. And they could do all of these things, I say simultaneously, but that may be wrong. And so how do we do this? Now, I'll tell you the other part of my class, because if that wasn't, I was like, well, that's not thinking big enough. Like you said, you want people to think big. So Mississippi is sort of at the bottom for a lot of things. So we took on the Mississippi AI Healthcare Challenge. So I had 5 teams, and the health card report is out there, 2025 Mississippi Health Report Card. And so one of these was gun violence. So their team, they're going to use, how can they use AI? And I said, no, you're not starting with generative AI. How can you use AI? Use something traditional like, neural networks, or use genetic algorithms. I'm old school, so I'm like, let's go back to the basics. And solve the gun violence problem. We have data sets. We need to combine data sets. Another thing that Mississippi's on the bottom for is infant mortality. What can you do as an AI enhanced approach to addressing infant mortality. Think big. And then there's another team that wanted to look at hypertension as the leading cause of heart disease. Another group wanted to look at obesity on an individual level. Another group wanted to look at obesity with a community-based AI-enabled approach. So they had data sets from the Mississippi Health Report Card, but we wanted to go beyond those data sets because many of the things the student identified as issues go beyond your traditional data sets. You need to combine data sets. If you're looking at gun violence, instead of looking at it generally, do you want to look at particular regions, or do you want to look at characteristics of those regions, such as employment rate and things like that? For obesity, students said, well, you know, they were excited about that because they said the class is obese. And I don't be looking at me. But no, I think they were talking about themselves, or collectively if we added everybody together. And so what are community approaches? When they looked at, for example, gun violence, one of our practitioners pointed out that the gun violence data doesn't give you the data for, 12 to 14 or 14 to 17-year-old? So
Yes.
when we looked at gun violence, they were missing a lot of the people that are committing some of the senseless gun violence. And then in terms of infant mortality, where do you put up some of the clinics or some of the mobile clinics? So we wanted to look at addressing these issues as a constraint satisfaction problems. So it's not like you change one thing and then you wait and see what happens. We can't wait in Mississippi. So how could you do this? They have the data sets. We talked about cleaning the data sets and then combining the data sets to have like a more comprehensive view of what's happening beyond what, you know, the State Department tells us. They had additional insight. So that's my challenge. And, you know, how to put computing in my class? I said, this is some one-on-one time.
Yeah, so this is wonderful. And I would admit that a tremendous value of the MSCC community is the effort that you are devoting to education and training. Because the higher you go in the hierarchy of institution, the more the emphasis is on research and less on education. So I am always impressed by the creativity, the commitment, the effort that goes into what you offer the students. That I find it more in the MSCC community than I find it in other places, and that's a different discussion. For me, sitting down and thinking through what the students will need would be extremely useful, and then we can identify where on our data sharing or compute sharing, or, you know, we can provide capacity and resources to support the students, with an understanding that if we want to support classroom, this is a huge commitment on our side. We have to be there at 9:30 in the morning on a Monday when everyone shows up at class. We have to run, I don't know whether you're using notebooks or not, we have to create, how many kids do you have in the class?
It was 22 this last
22.
semester, but I think it's going to be popular.
It will just go up.
Yes, it'll go up.
Yeah, so let's assume 30 kids.
Yes.
Can we provide each of them with a notebook with their own data and the capacity behind it to run it? But we have to be there at 9:30 in the morning on Monday, because otherwise we use credibility and the whole thing falls apart. So we have to plan on our side, and we have the capacity. But then it becomes an allocation, scheduling, planning, all the kind of thing, which is our expertise. But we need to work together. And working together, which is related to sharing, is building trust. Why would you use us if you cannot trust us? So we developed a relation with Jackson State over the last decade, right?
Yes.
And so far, we delivered most of the time. That builds trust. You know that if you need something, you
Absolutely.
can come and call me and things will happen.
Absolutely.
So that's sharing and trust. Is that, so how do you put together, also in the context of the MSCC, an understanding of how do you bring this kind of thinking? Because what you are describing is what we see in our world of research, that AI is not just training. AI is all about data.
Yes.
And where do you get the data, and how do you clean the data? And we see quite a bit of demand for simulation to generate data.
Yes.
Because if you don't have data, there's no AI. Just going like ChatGPT and sucking in all the stuff from the internet, that is not what enables you to deal with infant mortality in a state. That will not help you. So can you, as MSCC, come together? Because I was disappointed this morning. I went to a bird of feather about how do you educate the students, and there was the question of should they use it in classroom, not use it in classroom. But I didn't hear anyone talking about how do you get the capacity and how do you get the money to pay for the AI? And it sounds as if AI is free, but AI is not free. So this is going to create another barrier, right? Because we are looking at software and cybersecurity, and you pay by token now. And it quickly. It's like the cloud illusion. Oh, it's great. It's there, and we save a lot of money. Not really. Once the bills are, you see the bills.
I see the bills.
So how can you, as MSCC, figure out how do you bring together the tools and the capacity and the methodologies to do what you, because at the end of the day, you are the driver. Because you're in the classroom, you come up with the ideas, you're working with the students. We're in the back. You have the hard work. We have the easy work. But we have to talk so we know what to give you.
But we have time.
Yeah?
Because it'll be offered spring of next
when
year.
is dinner?
Yeah, okay, we're gonna get to that. But one more thing, because you said you wanted us to think big. So we took this, and beyond just computer science, we wanted to take this concept of introducing AI through wicked problems throughout the campus.
Yeah.
So Dr. Dent secured some money from Cisco
She will
Systems.
pay.
And we did a responsible AI challenge, and then we had a responsible AI writing retreat. Dr. Dent, you want to tell us about this? So we need to not just solve it for computer science and AI, we got to solve it across campus.
Some of my collaboration are with chemists. And I have a chemist that showed up and said, I want to do 200 million simulations of proteins. Okay, and then I got another one who came and said that 200 million is not enough. I want 4 billion. They're biologists, they're chemists, they're not computer scientists.
And as part of our infusion of AI throughout the entire campus, we have people from the art department and from English, really looking at authenticity and how do you, through the use of AI, encourage that. We have people from a public health college. We have people from education. So it's all over campus. So now we've just blown it up. to be across this campus with Dr. Dent's support and with Terry's support. So,
We see now in biology with AlphaFold,
yes.
want hundreds and hundreds of AlphaFold runs, and we are now creating libraries for it. There are ways to do things in a smarter way, but we have to share,
That's right.
and we have to establish trust.
Okay, well, I won't make you answer all my detailed questions. So those are the notes, those are the things that I won't forget.
Good.
But I know Terry wants to move on.
This is great. No rush, no structure
only have
necessarily.
5
We do
minutes.
have 5 minutes.
Do we have anything
From the audience.
from the brave people who came to this amazing exchange?
Damien.
No, I was just gonna, I do have a lot, but I'm gonna use this. So, one of the things that I did, like, I just want to say a comment to Dr. Miron. You hit the nail on the head because, like, some of the things that I've been looking at when you're talking about artificial intelligence, you're talking about the availability of it. What I've been looking at the people that got the money to pay for the high throughput computing, and they pay for the people to come train the models, and then when they're done paying for the people to come train the models, they've got the training and they've got the data, and they can still pay for more of the hardware and the cooling and everything else. So you're making a good point about the accessibility part of it, because nobody's really talking about that. We're talking about how great it is, but we're not talking about the availability part. So I appreciate that.
So you say you have the people with the money?
I don't have any people with any money,
I just gonna say,
but I know the folks that have the resources. They
So
purchase. You know.
So again, the challenge is for you guys, the MSCC community, to come together and to say we have to work together, because there will no magic solutions. You heard the DoD has a lot of capacity, and then you walk across the street and there's nothing. Am I exaggerating?
You're correct.
Okay,
Yes.
so we are across the street, so we can bring things together. And again, I'm showing you what we are doing on the OS pool. 400 million jobs in a year, 300 million core hours, okay, 700 users, 300 projects in a year, all benefiting. Why? Because we ship. So, but that requires your creativity, your commitment, your, and to work across the organization, because if each of you will try to do it separately, it won't work. And it will not come from somewhere. It will come from, and I believe there is quite a bit of resources in each of the institutions that is being pulled together. See, when we started, okay, let me connect it also to where we are going and the high throughput world.
Got about 2 minutes.
Two long minutes. So we started on workstations in the 80s, VAX stations, 2 MIPS machines, if some of you remember that.
punch cards.
Okay, today, if you want to buy GPUs, they only sell them in Iraq for the last generation and the next generation, $5 million a pop. Nobody in academia can afford it except for maybe the big facility. However, NVIDIA has already, and AMD is coming out with these little boxes, $6,000 a pop, that you can put on your desk. And you can do quite a bit with it. So I envision that we are going back the same cycle that we had with workstations 40 years ago, that the high end is out of reach for most institutions. But you can put these little puppies, and then we can pull them together the same way we did with Condor, with Workstation, 40, 45 years ago. So, but you have the structure, you have the MSCC, you have the organization, you are coming here, you're enjoying New Orleans, but there is an opportunity to come and join forces, and you can do great things.
Dr. Miron, we'll let you have the last word. If anyone wants to start working with the OSG, Path Project, University of Wisconsin with their HTC, what's your best advice?
They should talk to you. You.
There it is.
No, find us. We are out there, and if we don't respond, complain to Terry. He knows the secret handshake to get us to do things.
Thank you very much to our panelists. Thank you all for
Yeah, thank
attending.
you for coming.